Okay, let's start factoring. So first one we have here is x squared plus 3x minus 40. And we have no common factors, so we have to look for the method that we'll use. And in this case, it'll be sums and products. So we need two numbers that multiply to negative 40 and add to positive 3. And that'll be 8 and negative 5. So we end up with x plus 8 times x minus 5. Basically, we broke this middle term into positive 8x and negative 5x and factored by grouping. And we'll see that more clearly later on. Okay, so that's our factorization. Next one, p squared plus 3p plus 2. Again, no common factors, and again, sums and products. Two numbers that multiply to 2 and add to 3. That's going to give us p plus 2 times p plus 1. Okay, nice and easy. Okay, next one. What's going on here? Well, we have two terms. Let's see, both are perfect squares because 9's a perfect square. 2 and 4 are both even, so x squared and y to the fourth are perfect squares. 6 is even, so z to the 6 is a perfect square. So that gives us factorization by difference of perfect squares, giving us 3x y squared minus z cubed times 3x y squared plus z cubed. And the reason this works is that when we multiply it out, we get 3x y squared times itself, which gives us our first term. We get negative z cubed times 3x y squared, and positive z cubed times 3x y squared. Those two cancel out, and then we end up finally with negative z cubed times positive z cubed, which gives us our negative z to the sixth. Okay, next one here. All right, well, this time we do have a common factor, which is q. And so what we are left with then is 49q squared minus 14qs plus s squared. All right, let's see what we have here. All right, well, 49q squared and s squared are both perfect squares. So this could be a perfect square trinomial if double the square root of 49q squared times the square root of s squared gives us that middle term. Well, the square root of 49q squared is 7q, or negative 7q. And the square root of s squared is s, or negative s. So when we look at these two, negative 7qs, we're going to end up with a negative 14qs. So this works as a perfect square trinomial. So that means we're going to end up with q times 7q, and we'll do a minus s, and that will be squared. And that'll bring us back to our 49q cubed minus 14q squared s plus qs squared. All right, and again, first thing was to factor out the perfect square trinomial. Or, I'm sorry, factor out the common term, which was the q. All right, next one. All right, we have two terms here. Each term is composed of two factors. Do we have a common factor? Well, no, but we do recognize that we have a p minus 3 and a 3 minus p, which are negatives of each other. So we can rewrite this as p minus 3 times 2q plus 5 minus p minus 3 times 5 minus q. Now we do have a common term, and that's p minus 3, and that is what we will factor out, leaving us with 2q plus 5, and then minus our 5 minus q here. All right, again, we need to be careful here because we're subtracting this entire term, which means that this negative here is going to be distributed to the 5 and to the negative q. So we end up with p minus 3 times 2q plus 5 minus 5 plus q, which is equal to p minus 3 times 2q plus q, and then a 5 and a negative 5, so we end up with just the 3q. Okay, next one. Okay, we have two terms. 2x minus y squared, x plus 3y squared. We have a difference of perfect squares here, so we'll use that factorization pattern and we'll get 2x minus y plus x plus 3y times 2x minus y minus x plus 3y. And that will, when combined, give us 3x. And then we have plus 2y times, okay, so this becomes, we have a 2x minus x, or just x, and then we have a negative y minus 3y, so that'll give us minus 4y. So just be careful on the subtraction term, that when you're subtracting something in parentheses, that you make sure to distribute this negative to everything inside the parentheses. Okay, so that wraps up this page. Okay, so let's go on to the next page here. And we now have, okay, 10x squared plus 15x squared plus 6x plus 9. Nothing in common across all four terms, so we can't factor anything out. So what we can do is factor by grouping, and that's going to give us, let's see, when we group them, we're going to get a 5x squared as the largest common factor. So that'll leave us a 2x plus 3. And we can factor out a 3, which will give us a 2x plus 3. And now we can say we can factor out that 2x plus 3 from both of these terms. And what's left is 5x squared plus 3. Okay, let's check to make sure that we can't do any further factoring. Well, 2x plus 3 cannot be factored further, nor can 5x squared plus 3. So this is fully factored. Okay, next one, 10x squared plus, or 10x cubed plus 11x squared minus 6x. Okay, we actually can factor out an x to get 10x squared plus 11x minus 6. All right, so this can be further factored. Or at least we're going to investigate that. And it can be fully factored if we can find two numbers that multiply to 10 times negative 6, or negative 60, and add up to 11. Well, there are two such numbers, and they are, one will have to be positive, one will be negative, and that's going to be negative 15, or positive 15 and negative 4. So that's what we'll break our middle term into. So we'll end up with x times 10x squared plus 15x minus 4x and then minus 6. All right, inside here we get that we can factor this as 5x times 2x plus 3 minus 2 times 2x plus 3. That will give us x, and then we'll factor out this common 2x plus 3 to get 2x plus 3, and what's left is our 5x minus 2. Okay, fully factored. And if we had set this equal to 0, we would have had three different solutions. X is 0, x is equal to negative 3/2, x is equal to positive 2/5. That makes sense because we have a cubic, which is to say that the highest exponent in this is a 3. Okay, so let's keep going here, and we're going to use factoring to help solve these equations. Okay, first one, well, this is a sums and products. Two numbers that multiply to 8 add to 6. No problem. We get x plus 4 times x plus 2 is equal to 0. And that means that our two solutions, we get x is equal to negative 4 and negative 2. That's our solution set. Okay, next one, x squared minus 3x equals 28, set equal to 0 first. Okay, since we're using factoring, we want to set this equation equal to 0. So we get this, and see, can we factor this? Well, do we have two numbers that add to negative 3 and multiply to negative 28? Yes, we do. We have x, and we can break this into x minus 7 times x plus 4 equals 0. And again, using the zero product property, which says that when we have two things that multiply to 0, one or both of those things have to be 0. And so in this case, we would get 0 when x is equal to 7 or when x is equal to -4. So that's our solution set. Okay, next one. Now we have, let's look at this. It's equal to 0. And the question is, can we factor this? No common factors. So let's factor by grouping. And out of the first two here, we would take an x squared, which would leave us with x plus 3. And we would take a -4, which would leave us with x plus 3 equals 0. That would give us x squared minus 4 times x plus 3 equals 0. Notice the x squared minus 4 can be further factored into x minus 2 times x plus 2 because it's a difference of perfect squares. So we end up here with three solutions. We have x could be equal to 2, x could be equal to -2, or x could be equal to -3. That's our solution set. And again, three solutions, cubic. So that's a good check. Okay, let's keep going here. And we'll go to our next page. All right, what do we have here? We have 3x squared plus 20x equals 7. All right, well, that means that we want to set it so that we have 3x squared plus 20x minus 7 equals 0. Well, if this can be factored, it'll be by sums and products, and we'll be looking for two numbers that multiply to 3 times -7, which is equal to -21, and add up to 20. Okay, so that would give us the numbers negative or positive 21 and -1. So we would break this, 3x squared plus 21x minus x minus 7, and again equals 0. And by factoring by grouping, we get 3x times x plus 7 minus 1 times x plus 7 equals 0. We would factor out the x plus 7 to give us x plus 7 times 3x minus 1 equals 0. That would give us the solutions of x would be equal to -7, or x would be equal to positive 1/3. Okay, solved. All right. Looking at the next one here, solve by completing the square. Okay, when we're completing the square, the easiest way, it's not the only way, but the easiest way is to make sure all constants are to the right and that the coefficient of the x squared term is 1. Okay, so that's already been accomplished here. So now what we need to do is to add whatever we need to do to make the left side a perfect square trinomial, and then we'll add that to the right side as well. So what that means is that we need to take 6 divided by 2 and square it. And we know that's just equal to 3 squared, so we're going to add that to this side as well. What that means is that because this is a perfect square trinomial, we can factor it to x plus the square root of this number here, which is just going to be 3. This whole thing squared is equal to 19. Okay, the reason we do that is that we can now take the square root of both sides. X plus 3 is equal to the positive or negative square root of 19, and x therefore is equal to -3 plus or minus the square root of 19. Okay, so that's solved. All right, taking a look at this next one here. Okay, so we have the constant on the right, but what we want to do now is divide through by 2, and that'll give us x squared minus 5/2 x is equal to 5/2, and I'll leave room for our terms. So now we want to take half of -5/2, which is -5/4, and square that and add it to both sides. So now we have plus -5/4 squared equals 5 halves, and then we'll just square out that 5/4. We know that's going to end up being 25 over 16. So that means on the left-hand side, we can just factor this to x minus 5/4 squared is equal to, well, this will be the same as, let's see, since we want a common denominator of 16, we'll get 5 halves is going to be equal to, we'll multiply top and bottom by 8, it's going to be equal to 40 over 16. So now we have this, 25 over 16. Okay, so we get x minus 5/4 squared is equal to 65 over 16. That means that x minus 5/4 is equal to plus or minus square root of 65 over 16, which means that x is equal to 5/4 plus or minus the square root of 65 over 16. Now, what we also recognize is that 16 is a perfect square. So we can say this is equal to x is equal to 5/4 plus or minus the square root of 65 over the square root of 16, or x is equal to 5/4 plus or minus root 65 over 4. Or in our final version, x is equal to 5 plus or minus root 65 over 4. Okay. Next, use factoring to simplify this expression. Before expanding, think about how the numerator contains one of our factoring patterns. Okay. All right. So what we see here is that our numerator is a difference of perfect squares. So rather than expanding, I'm going to see what happens if I just go ahead and factor that top part to get 2x minus 3 plus x plus 2 times 2x minus 3 minus x plus 2 all over, and I'm going to factor this thing too, just to see x minus 3. All right, so up top we're going to end up with 3x minus 9 when I simplified this term, times, we're going to get a 2x minus x, or x, and then we have a minus 3 and a minus 2, so that's going to give us minus 5, all over 5 times x minus 3. Well, this top term, this 3x minus 9, can be further factored to 3 times x minus 3 times x minus 5 over 5 times x minus 3. We can see that our x minus 3 cancels out. We end up with 3 times x minus 5 over 5 as our final simplification of this. Okay, we're done.